Static variables with inheritance sometimes cause confusion. It's also good to be careful about that. Let's see this code. We have here class A, which has a shared variable 10. But class B has its own shared also static variable with 5. And we have function f that is printing 3 things. So let's trace the code. We have an object from B, and then we printed b.f. We actually, evaluated b.f. Now let's go here. The first thing is self.shared. What is self? Self is b. So self.shared b is 5. Be careful, what is self? The second one, a.shared. This is very direct. This is a, so a.shared is 10. The third one is type of self.shared. Type of self.shared. What is type of self? Self is b, so its type is b. b.shared is 5. Now, let's go one more step. b.shared equals 7. Now we are changing the object b on a static level, so now its internal 5 is going to now to have an object level shared as 7. So this shared is actually now an attribute on the object level itself. Remember what we learned in the static variables. Let's call f again. Self.shared is referring to what? Shared here is this attribute that we did here, as we learned before in the static variable class. A.shared is again referring to that guy. Now type of self.shared is referring to this one here. And this is one advantage for using self with type actually. So before I warned you from playing with the static variables with self.shared. But using type with self is going to bring the class, and now this shared is definitely referring to this 5. So the moral of that is, I would like you to be very careful about what do you really mean. Okay, definitely avoid adding attribute to your object that has the same name as your class to avoid problems. But as you see, there is a great added value here when we use type of self. We guaranteed to access the class level here without referring explicitly to its name. And again, remember what is self, because in inheritance hierarchies, the self is going to refer to the child class, not to the parent class. Another example. We have here class A shared, and we have here B and C who doesn't have this shared class, shared static variable. If we try to print all of them, then we are going to have the same value referring to the A. If we started to say A.shared equal 3, at this moment we added a static variable to A to be 3. If you try to print it, still all of them here, these two guys, are referring to the shared which is changed to 3. Now let's try to say B.shared equal 5. At this moment, B has its own static variable shared 5. If you try to print, you will notice A and C are still referring to the class A, but B is referring to its current shared copy. This is where you should remember the MRO. The MRO, when we write B.shared, started to ask B, do you have shared? Yes, printed 5. C, do you have shared? No. Does your parent have shared in the MRO? Yes, so use it. Let's now give shared for the A with 7. If you try to print A and C, again they will refer to 7, but B still has its own 5. Overall, to be good with the static variables and inheritance, you have to keep in mind two things. The first is the MRO rules, and the second to remember what we learned in the static variables and the issues involved with them. So be careful with the static variables in inheritance to not make mistakes. You can also override methods, but nothing here different. Like we have here hello and world, but we override here world. So world will be visible from that guy, but hello will be visible from that guy. This is very intuitive, nothing specific. That's all.